I want to look at inverse hyperbolic functions. But before we do that, let's be reminded of the inverse trigonometric functions. You might remember that, for example, the sine of 30 degrees is equal to 0.5. Alright? That's when you're working in degrees. You have 0.5. Even though with hyperbolic functions, we don't work in degrees, we work in radians at all times. Alright? But here, suppose you are given that the sine of an angle theta is equal to 0.5. You don't know what that angle is. What you do is say that theta is equal to the sine inverse of 0.5. So, sine inverse of 0.5 is equal to theta, whatever theta is. Alright? If you're asked, what is the sine inverse of theta? What is the sine inverse of 0.5? Then what you're really asking is what is the angle when you find the sine of it, you get 0.5. So the sine of theta is 0.5, it means the sine inverse of 0.5 is equal to theta. Alright? Now, let's look at the hyperbolic functions. Here, suppose, for example, you're asked to find out what is the sine inverse of, yes, say 1.6. What's the sine inverse of 1.6? What you're saying is that whatever it is, you don't know. So let's call it x. The sine inverse of, let me make this not look like a h2. The sine inverse of 1.6 is x, whatever x is. What it means is that the sine of x will give you 1.6. Alright? If you find the sine of x, you're going to get 1.6. Now, the sine of x, as you remember, is equal to e to the power of x minus e to the power of negative x divided by 2. That's sine x. So therefore, e to the x minus e to the negative x over 2 is equal to 1.6. So you want to find out what x is. Remember that x is the sine inverse of 1.6. If you find the sine of an angle, you get 1.6. The question is, what is that angle? And we call it x. So we are trying to find out that angle, which we call x. What is x equal to? So let's do some arithmetic on this thing. Suppose you multiply both sides by 2. You have e to the x minus e to the negative x is equal to what? 3.2. Alright? Now, this is the same as e to the x minus 1 over e to the x equals 3.2. Alright? Suppose you multiply both sides by e to the x now. You'd have e to the x times e to the x minus 1 over e to the x. It would cancel itself. Right, when you multiply it, so you get 1 equal 3.2 times e to the x. Alright? Because you multiply everything by e to the x. So what you have is e to the x squared minus 1 equals 3.2 e to the x. Alright? Now, I can see here that this is taking the form of a quadratic equation. You have something here squared, and you have the same something here times a number. So let's set it up to look like ax squared plus bx plus c equals 0. Now, you have x in here already, so let's use a different letter. A p squared plus bp plus c equals 0. Alright? So here now, e to the x squared minus 3.2 e to the x minus 1 equals 0. Alright? So, let e to the x be equal to p. Let's change it and call it p. What we have is p squared minus 3.2 p minus 1 equals 0. It would be easier to deal with mentally if you just use one letter instead of saying e to the x. Alright, now we can use completing the square. Well, completing the square would be a bit more difficult here because we have 3.2. Well, it shouldn't be so bad. But anyway, let's use the quadratic formula. Let me see something here. Let's use completing the square, right? Because it's good to review how to solve quadratic equation by completing the square. Alright. So remember, with completing the square, you like you're saying x plus h squared. And that is the same as x squared plus 2hx plus h squared. Right? Now, here, instead of x is p, you have p squared minus 3.2p. Right? Let's put the minus 1 out here equals 0. We want to set this up to make a perfect square, because remember, out here, this is a perfect square. And it can be written in this form. You see that? Here. You have to remember you're completing the square, you know. So here now is x squared plus a number x plus this number, you know, this number x is 2h. If you halve 2h, you're going to get h. And if you square, you get h squared. So this is the same as plus negative. So the number that multiplies p is negative 3.2. Now, half 3.2, just like how you half the 2h here, you half 3.2. When you half 3.2, it's negative. When you half negative 3.2, what is going to lead to is negative 1.6. And when you square it, you get negative 1.6 squared, right? So you plus negative 1.6 squared. See that? Now, you have this part set up exactly as you want. But the fact is, you just added negative 1.6 squared. So it will change the equation. You have to remove it. So whatever you added, you have to remove it to get back the original equation. You have to say minus negative 1.6 squared equals 0. You see this part now? It can be written as p plus negative 1.6 all squared. Alright? Then you say minus 1 minus what is negative 1.6 squared. Let us see. It's good to be able to use the completing the square in case you don't remember what the quadratic formula is, and also you might not be given a formula sheet with it. So negative 1.6 squared. 1.6 squared is 2.56. It's the same as negative 1.6 squared because the negative sign will disappear. So it's 2.56, right? Minus 2.56. So this is P minus 1.6 all squared minus, it would be 3.56 equals 0. So what you could say now is P minus 1.6 all squared is equal to 3.56. Square root both sides now. The square root of P minus 1.6 squared is equal to positive and negative square root of 3.56. What's the square root of 3.56? Let us see. What the square root of 3.56? The square root of 3.56 equal 1.887. Right, 1.887. Alright, now the square root of this squared is it itself. P minus 1.6 is positive and negative. Positive and negative. 1.887. So P is equal to 1.6 plus or minus 1.887. Now, therefore, P equals, let's work with both numbers that we will get and see how things will work out after this. Alright? Now, we have 1.6 plus 1.887, 1.6 plus 1.887 equal 3.487, and also 1.6 minus 1.887 negative 0.287. So 3.487 minus 2.8 minus 0.287. 3.487 negative 0.287. 3.487 negative 0.287. So either that or that. Now we got that for P, right? Now let us see what's going on here. E to the x is P. So e to the power of x is 3.487, or e to the power of x is equal to negative 0.287. Alright? Now, here, what we can do is log both sides. Ln e to the x is equal to ln 3.487. Now, this, based on the rules of logarithm, can be written as x ln e equals ln 3.487. Now, we can't scroll down any further. So let me just draw a line here to divide the screen and continue up top here. Alright, so what we have, x ln e equals x ln e equals ln 3.487 equals ln 3.487. And for the other solution, e to the x is minus 0.287. Also, e to the x equal negative 0.287. But let's deal with this one first. ln e is 1, so x is equal to ln 3.487. What is ln 3.487? Let's find out here. ln 3.487 equal 1.249. So 1.249. Alright, so we got that part. What happened with this? If we ln both sides, we have ln e to the x equals ln negative 0.287. So x ln e is equal to ln negative 0.287. ln e is 1, so x is equal to ln negative 0.287. What's going to happen when you find the logarithm of a negative number? Let us see what happens. So, if you say ln of negative 0.287, you get I, and I number is an imaginary number. Some other calculators will give you an error message, right? So, for example, this one, if you say ln, let me clear it. So ln, you have to press the number first and then ln with this calculator. So negative 0.287 ln. Let me see. Open bracket. Let's clear it to make sure. Open bracket. Oh, this calculator is kind of funny, you know. 0.287. The negative 0.287 ln. Alright. It says NaN. Right, which means an error message. This one gives the error message because it's an imaginary number, but this is programmed to give you the imaginary number, because you can't find the logarithm of a negative number as to y. We can see here. Alright, let's look at y after we test this solution and see what happens. So what we're saying is that the sine of x is 1.6. So sine of 1.249 is supposed to be 1.6. Is that so? Let us see what's going to happen here if we find the sine of that number directly with our calculator. It's clear, and say the sine of 1.249 equal we get 1.6. So we get 1.6. So it is correct. Alright. Now let's come back to this. You cannot find the logarithm of a negative number. This is in logarithmic form, but this is in exponential form or index form. Right? Now, let's be reminded of that part. If you find log base 10 log of 1000, the base is 10, you get 3. Now this is going to mean that 10 to the power of 3 equals 1000. 10 to the power of 3 equals 1000. Now let's find the ln, the natural log of negative 0.287. ln negative 0.287 equals x. We want to find out what x is. But what is ln? ln is the logarithm of negative 0.287. And where the base of the logarithm is e. And that's x, whatever x is. When you rewrite this in exponential form, it's going to be e to the power of x equals negative 0.287. It comes right back to what we had up here. E to the x is negative 0.287. See that? Now, what could x possibly be? Let's say x is 5, e to the 5. What is e to the power of 5? Let's find out here. So e to the power of 5 equal 148 something. Now to 3 decimal places, e is 2.718. Alright. So if your calculator doesn't have e on it, which I would doubt, maybe you would need to buy a new calculator if that is so. But it's 2.718, 2.718 to 3 decimal places to the power of 5 equal. See, 148 point something. It's very, very close. It's a 148.336 as opposed to 148.413 for the accurate value. But anyway, we say that we get a large number here when we say e to the 5. Let's put e to the 1. Alright. E to the 1 equal. It's just e. So e to the 5 is 148, too large. With e to the 1 is just e, which is 2.718. E to the 0 would be 1. Number still too large. Suppose you say e to the negative 1. You same as 1 over e, right? So what is e raised to the power of negative 1? Let's get rid of this. So e raised to the power of negative 1 is 0.367. Okay, it's getting smaller. E to the power of minus 2. We're getting close to 0, and then we try to go negative. Suppose they say e to the power of negative 100. Well, it's close, but because we're rounding off. But e to the power of negative 10. Very small. E to the power of negative 20. Even smaller. E to the power of negative 30. What would that give you? Very close to 0. E to the power of negative 25. E to the power of negative 21. It's getting extremely small. Now, you will see that for extremely small numbers, the calculator round it off to 0, but it's not 0. If you say e to the power of negative 100 is 100 over e to the 1 is 1 over e to the 100, right? It's very close to 0. You might have e to the negative 1000, meaning 1 over e to the 1000. It hasn't reached 0 yet, but you're getting closer and closer. Now, e to the negative big number, or 1 over e to the big number, very small, close to 0. So theoretically, in order for you to get to 0, you'd have to say e 1 over e to an infinitely large value. So if you have to do that, which is not possible, because you're talking about e to 1 over e to an infinitely large value, you could not get into the negative the negative area, right? You couldn't. You can say e to a number and make the number smaller and smaller, right? And you have an answer that is larger than 0. But getting smaller and smaller, and your answer will be getting close to 0. But you cannot reach 0. So if you can't reach 0, how are you going to pass 0 and go down into negative? So that's why you get an error message there. Alright, you cannot find the logarithm of a negative number. Alright, so that's it for now. I'll see you in the next video.